Good morning, students. Today we are going to discuss about the various methods that are used for determining pH. So before starting the topic, we should know what is meant by pH first of all. Coming to the definition of pH, pH is defined as the negative logarithm of hydronium ion concentration. So if you are taking pH, it can be defined as the negative logarithm of hydronium ion concentration. So that is the definition for pH. So why we should go for determining the pH? Mostly we have to determine the pH when we are considering the liquid dosage forms. Okay, especially the parenterals or the eye drops or the ear drops. Okay, in such conditions we need to know what is the pH of that particular dosage form. So for determining this pH we are having two different methods. So those two methods are, the first one is calorimetric method. First method is called as calorimetric method and second one is called as electrometric method. So calorimetric and then electrometric methods. So first one, coming to the calorimetric method. In calorimetric method, we have to prepare different kinds of standard buffer solutions ranging from pH 3 to pH 11. So we have to take different kinds of test tubes. So we have to prepare different kinds of pH standard buffer solutions ranging from 3 to 11. Okay, so each interval is pH 1 unit. One pH unit interval you have to consider and you have to prepare different kinds of standard buffer solutions. In the next step, we have to add universal indicator. We have to go for adding universal indicator in each of these test tubes or standard buffer solutions. So once we are adding this universal indicator, we will get different types of colors. We will get different types of colors for individual standard buffer solutions. So pH 3 will have a different color, pH 4 will have a different color, like that each will have its own different colors. Now the next step is we have to take the test tube containing test solution within it. Okay, previously we have standard buffer solutions where we have added the universal indicator and each buffer standard solution we are having different colors. Now the actual step is we need to take a different beaker which will be filled with the test solution. So to this test solution also we have to go for adding universal indicator. Okay, after adding the universal indicator to the test solution, definitely it will give some color. And we have to go for matching this color with the above prepared standard buffer solutions. We have to see which color is matching to the above prepared standard buffer solutions. Okay, for example, the given color is near to 8 and 9. Okay, it is not exactly 8. It is not exactly 9. So the next step is we have to prepare different kinds of standard buffer solutions having 0.2 unit intervals. The pH unit interval, the first step is 1 pH, 3, 4, 5, 6, 7, 8, up to 11. In the next step is we know the color is matching between 8 and 9. Now we have to prepare 8.2, 8.4, 8.6, 8.8 and 9. Like this, again we have to go for preparing standard buffer solutions. Okay, previously 1 pH unit interval, now 0.2 pH unit interval. Again, universal indicator is should be added. Okay, now again each of these standard buffer solutions will give a designated color. Now we can go for having the exact pH of the given test solution. Still, if you are not having any clarity or accuracy in the pH value of the given test solution, the next step we have to go for making a pH unit interval of 0.1. Okay, so we have to make 8.1, 8.2, 8.3, 8.4 up to 9. Okay, like that it is a time taking process. Hence, we should go for opting another method called as electrometric method, which is mostly preferred, which will take less time and which will give accurate result also. Okay, so coming to the second method now. For this electrometric method, we need to use an equipment called as a pH meter, electronic pH meter. So here, before going to take the test solution, to get the electrode immersed in it, we should go for calibrating the equipment. So how we have to go for calibrating the glass electrode of the pH electronic meter? How we have to go for calibrating it? Similar to the previous method called as calorimetric method, here also we have to go for immersing the glass electrode in the known standard buffer, 4, standard buffer 6 or standard buffer 8, like that. And we have to check whether the given glass electrode is showing the similar pH on the readout device or not. Okay, for example, if it is having slightly lesser than the actual value or slightly higher than the actual pH value, then we have to go for adding acids or bases. Okay, to adjust the pH to the given standard buffer solution. Okay, after doing that, the calibration step will be over. Now the glass electrode should be rinsed with the purified water. Okay, because we have immersed that glass electrode in a known standard buffer solution. Okay, now we are going to dip that in the test solution. Some of the part of standard buffer solution will be sticked over the glass electrode. So we have to rinse that properly with the purified water. After rinsing that, we have to dip the similar electrode in the test solution. Now it will show the reading over the readout device. So that pH will be considered as the value of the given solution, test solution. pH of the given test solution. So like that we can go for determining the pH by means of two methods called as calorimetric method as well as the electronic method or electrometric method. So after this we will see about the Sorensen's pH scale. So in case of Sorensen's pH scale, the scale starts from reading 0 and it will end at 40. So it will start from 0 and ends at 40. In the center it will have a value of 7, which is called as neutral. From 0 to 7 it will have acid properties, whereas from 7 to 40 it will have alkaline or basic properties. Okay, and here it will have a value of 10 over 0 and here 10 over minus 40. Okay, so Sorensen's pH scale consists of readings from 0 to 14. In the center it will have a reading of 7. From 7 to 0 it will be considered as acidic nature, and from 7 to 14 it will have alkaline nature or basic nature. Okay, and the center 7 will be considered as the neutral pH. Okay, that is about the Sorensen's pH scale. Thank you.